let's see how we actually interact with level of detail and aggregation in visualizations. So we've seen static data, we've seen tables in Tableau, but really this was all in service of seeing in real visualizations how level of detail and aggregation interact to make the things that we're actually going to show viewers. So let's start with the simple one. We'll do a more complicated one in a moment. Let's drag CO2 emissions to columns and energy usage to rows. And notice that we get a single mark. And so right now you have to ask yourself, what level of detail are we operating at? And this is kind of a weird one, right? Like we only have a single mark. And so what's happening here is that we have aggregated over all countries, over all years. Because we've aggregated over all countries, we've aggregated over all regions. And we can verify that by actually just looking at the data. So this is the entire data set. Like if we look at the full data set, we've got Algeria in 2000 all the way down to Guatemala in 2012. And notice that these may not be sorted in any particular order that we care about. And we may only have some countries in 2012 or whatever, but this is the entire data set boiled down to a single value, the sum of CO2 emissions and the sum of energy usage across all countries, across all years. If we want to change this, we can do a couple different things. We can make the level of detail finer, for instance, by dragging region to color. Now notice what this does. It automatically makes a different mark, one of each color for each region. So orange is Asia, yellow is the Americas, and you have to ask yourself, okay, so now we're operating at the region level of detail. What does each data point represent? It represents the sum of that region's CO2 emissions and that region's energy emissions across all countries in the region, across all years in the data set. And we can confirm this by looking at the data point itself. So here, if we look through, this is Asia. We go from Afghanistan in 2000 all the way down to countries in 2012. And again, they may not be, the list does not necessarily have to be sorted in any particular order. And so we have to kind of look through and verify or trust in some sense perhaps that it's every country in every year. We've boiled everything down. Basically any row that has a value of region equal to Asia in the data set has been condensed into this single data point. We're operating at the region level of detail. We can go even more fine-grained by dragging country region to detail. And so now we have 1 point per country colored by region. So the level of detail here is actually country, not region country, because remember, region is kind of strictly coarser than country. And so if I click on United States and I look at the data set here, what data have been boiled down to form this? Every data point that has a country region equal to United States. So that's from 2000 to 2012 in this particular data set. So this is all the data that went into making this point. You can always do this. If you're asking yourself kind of like, well, what does this point represent? You can always take a simple look at the data. Now, even once we have the data though, there's the question of what the aggregation and what the aggregation is showing. So remember, this is the total CO2 emissions and the total energy usage of the United States across the entire length of the data set. Now this is important because it's not necessarily the per year, like the annual output or the per capita output or something like this. We do have to be really careful. Let me show you an example where that'll matter more. So let's do life expectancy male, and we'll drag that to columns, and we'll do life expectancy female, and we'll drag that to rows. We'll drag region to color. And notice, first of all, that these things are completely ridiculous. That there's no country that, let's do one more. We'll make it even a little bit better, and it's still bad. Notice that if we drag country region to detail like we did earlier, we have 1 point per country. So we're operating at the country level of detail, but these life expectancies just don't make any sense, right? 700 is not a reasonable life expectancy, and that's because we're aggregating by the sum. So notice, for instance, if I look at Sierra Leone and I look at the data here, how did I arrive at that life expectancy? I went through and I added all of these values. So to get life expectancy female, I added all of these values. Life expectancy male, I added all of these values. But that's not what I really care about. That's not like the public health measure that I'm tracking, right? Instead, I should look at the average. So to change the aggregation, I go to measure, average, and I'll do that for both of them. And these look, so notice it really has changed the shape of the data set. So notice there were some pieces down here that had like some very low looking values. And you might say to yourself like, wow, like the Marshall Islands, yikes. Like they're doing so much worse than the rest of the world. And if we look at the data set, the reason this is happening is because there are fewer values. So if we go over to life expectancy, they only reported their values in one of these 12 years or 13 years. This is why if we're looking at the sum, they look so far away from the groups that reported in every year. Because if we sum and we only have one known data point, that's the entirety of the thing. But if instead we look at the average, all of this stuff becomes much more in line. And so we can actually, take away that that bias that for low reporting regions or low reporting countries, and present a visualization that's much more meaningful and much less misleading than other pieces. Sometimes this average is not good enough. We need to be very careful with that, and we're going to talk in the next video about places where the average can fail us, not just the sum, not just the average. We need to do something even more complicated. The point here, though, is to always remember what is going on in terms of level of detail. Be very cognizant of what levels of detail you've added to the visualization, and then the flip side of that is if I then look at the data, what am I aggregating across? So if I look at the full data, I'm saying what is getting boiled down to make this data point? Is it all years? Is it all product categories? Is it all customer types? Like what is going on here? And then based on what's being boiled down, what is the appropriate aggregation function for that? Is it average? Is it the sum? Is it something more complicated? So more on that coming up in a future video.